Welcome to Programming Fluency. This is section 2.5, Type Conversion and Constants. Real programs mix types all the time. In this video, you learn what happens when the types do not match, how to take control with a cast, and how to name values that never change. Let's begin. Let's start with a warning. When you assign a double to an int, C does it without complaint, and it quietly throws away the decimal part. No error, no crash, just a silent loss of data. In this section, you learn when C converts types for you and how to stay in control. Here is the plan for this video. First, we look at implicit conversion and the type hierarchy. C can automatically change a narrower type into a wider one, following a ladder that runs from char up to double. Next, we compare widening and narrowing. Moving up the ladder is called widening, and it is safe. Moving down the ladder is called narrowing, and it can silently lose data. Then we look at explicit casts. This is how you take control and convert a value on purpose, using the target type written in parentheses. After that, we meet the sizeof operator. It asks the compiler how many bytes a type takes, and the answer is worked out at compile time. Finally, we look at constants. You will see two ways to name a value that never changes. The const qualifier and the pound define directive, and we talk about which one to prefer. Real programs mix types all the time. A function returns an int and you store it in a double. A measurement arrives as a double and you need a whole number. The types do not always line up. When the types do not match, C performs a conversion. Sometimes that conversion is helpful, sometimes it is destructive. Understanding when these conversions happen prevents a whole category of bugs that are hard to track down. When you use two different types in the same expression, C automatically converts one to match the other. You write no extra code. The compiler handles it silently. We call this an implicit conversion. It is an automatic conversion the compiler performs when an expression mixes types. C changes the narrower type into the wider type so that no information is lost. The rule is simple. The narrower value is promoted to the wider type before the operation runs. Wider means more bits or more precision. Let us build the ladder from the bottom up. At the very bottom is char. A char is 8 bits, and it is the narrowest type here. One step up is short. A short is at least 16 bits, so it can hold more than a char. Above short is int, the everyday integer type. It is also at least 16 bits and usually wider. Next comes long. A long is at least 32 bits, so it can hold larger whole numbers. Now we move into the floating point types. First is float, which is 32 bits and can hold a fractional part. And at the very top is double. A double is 64 bits. It is the widest type on the ladder and the safest one to convert into. Now look at the green arrow on the left. Moving up the ladder is called widening. Widening is safe because the wider type has room for every value the narrower type could hold. No data is lost. Now look at the red arrow on the right. Moving down the ladder is called a narrowing conversion. Narrowing is dangerous. The smaller type may not have room for the value, so C can silently drop the part that does not fit. That is data loss. Here is widening in action. We have an int called count holding 10. We store it in a double called average. The value 10 is promoted from int to double and stored as 10.0. No information is lost. Now look at the second example. We add an int called x to a double called yc promotes x to 5.0 before doing the addition. Then 5.0 plus 2.0 gives 7.0. The result is a double. The dangerous direction is downward. C drops the bits that do not fit. No error, no stop. Here, pi holds 3.14159. We assign it to an int, and the fractional part is lost. Then we take big, which holds 100,000, and store it in a short. Look at the output. Truncated becomes 3, and small becomes negative 31,072. A signed short can only hold up to 32,767. 100,000 does not fit, so the low 16 bits are reinterpreted. That is surprising and dangerous. There is a subtlety with char. In arithmetic, C promotes char and short values to int before any operation. This is called integer promotion. Here A holds the letter capital A, which is 65, and B holds a space, which is 32. We subtract B from A and store the result in diff, which prints 33. Even though A and B are both char, the subtraction runs with int arithmetic. Why does C do this? To prevent overflow. Two char values might exceed the 127 maximum of assigned char, but the result is safe inside a 32-bit int. Sometimes you want a conversion. Maybe you need division to give a decimal result. An explicit cast tells the compiler exactly what you intend. You write the target type in parentheses right before the value. For example, open paren int close paren 3.7 produces 3. It says, I know this changes the type, do it anyway. Here we cast A to a double before dividing. Without the cast, A divided by B would be integer division and give 1. With the cast, A becomes 5.0, so the division is floating point. The result is 1.666. So when should you cast? Cast to force floating point division when both operands are int. Cast for intentional truncation, when you want the whole number part of a double. And cast to suppress a warning, but only after you have checked that the conversion is safe. When should you not cast? Do not cast to hide a bug. If the compiler warns you, understand why before you cast the warning away. And do not cast reflexively. A safe widening cast is just visual noise with no benefit. The sizeof operator returns the size of a type or a variable in bytes. The answer is worked out at compile time, so no code runs. It comes back as a size t value. On most 64-bit systems, sizeof of int gives 4, and sizeof of double gives 8. We print the result with the %zu format specifier. Sizeof lets you write portable code, instead of assuming an int is 4 bytes. One important detail. The expression inside sizeof is never actually executed. Look at this example. We put x++ inside sizeof. It looks like it should increment x. It does not. The compiler only needs the type of x to find its size, so it never evaluates the expression. After this line, x is still 5, not 6. Some values should never change after you set them. Pi, a maximum size, a tax rate. The const qualifier prevents accidental modification. Const makes a variable read only after you initialize it. Any attempt to assign a new value is a compiler error. Here pi is a const double and max students is a const int. If you try to assign to pi later, the compiler stops you. A const must be initialized when you declare it. By convention, we name constants in all capital letters. C has a second way to define constants. The pound define preprocessor directive. It works differently from const. It is textual substitution, not a variable. Before the compiler sees your code, the preprocessor replaces every occurrence of the name with the given text. No variable is created. No memory is used. It is a find and replace. Notice there is no equal sign, no semicolon, and no type. If you add a semicolon, the semicolon becomes part of the substitution. That is a bug. Let's compare the two. Const has type checking because it has a type. Pound define does not because it is raw text. Const follows normal scoping rules. Pound define is global from the point of definition. In a debugger, const shows the variable name. Pound define shows only the raw value. And const is a variable in memory, while pound define is inline, with no memory. The recommendation is simple. In modern C, prefer const. It has a type the compiler can check. You will still see pound define in older code and standard headers. That is historical convention. Let's look at a common mistake, silent narrowing. You assign a double 3.7 to an int. You might expect 4, but value is 3. The 0.7 is discarded, not rounded. Truncation always moves towards 0. This bug is dangerous because 3 is a perfectly valid integer. There is no crash and no error message. The fix is to be explicit. For truncation, cast to int. For rounding a positive number, add 0.5 before the cast. Here is a second common mistake. An imprecise pound define constant. You define pi as just 3.14. That has only 3 significant digits, but a double can store about 15. For a circle with radius 100, the area is off by roughly 31 square units. For engineering or scientific work, that imprecision matters. The fix is easy. Use the full precision that a double supports and write out all the digits of pi. Let's recap. C automatically converts between types when expressions mix them. Widening is safe and silent. Narrowing loses data. Livening like int to double is safe. Narrowing like double to int truncates the value. It does not round. Use an explicit cast, the target type in parentheses, when narrowing is intentional. It documents your intent. Const gives you a typed, scoped, read-only value. Pound define is textual substitution. In modern code, prefer const. And Sysioff returns the byte size of a type or a variable, worked out at compile time. Next, in Chapter 3, Control Flow, every program so far does the same thing every run. You will learn if else, switch, and the loops that let programs make decisions and repeat actions.